Toshiba Device and Storage Corporation. E-learning. Basics of Load Switch ICs. In this e-learning course, you will learn the basics of Load Switch ICs, operation, features. Chapter 1, Introduction to Load Switch ICs. What is a load switch IC? A load switch IC is a semiconductor switch inserted in series between a power supply and a load circuit or IC. The use of load switch ICs simplifies: 1. The supplying of power to each system block, 2. Power supply sequencing for ICs, and 3. Circuit protection from system failure. Take, for example, mobile devices and energy-saving equipment powered by a lithium-ion or other type of battery. These electronic systems save power by enabling only the essential circuit blocks and shutting down all the others. The figure on the left shows an example of using load switch ICs 1 to 4 to control the supply of power to 4 loads according to the states of a system. The figure on the right shows an example of using load switch ICs 1 to 3 to set a power sequence for the subsequent IC. Load switch ICs are power management ICs with an internal switch that exhibit a minimal voltage drop in power dissipation because of low on resistance and low quiescent current. Load switch ICs help improve the stability and reduce the size of an electronic system because they incorporate various protection functions and require fewer components than a load switch circuit composed of discrete devices. Benefits of using load switch ICs. Figure shows an example of a simple load switch composed of discrete devices. This circuit consists of a MOS-pass transistor, a MOSFET gate driver, resistors, capacitors, and input and output smoothing capacitors. In a simple load switch circuit configured with discrete components, when the condition Vout more than Vin, the body diode conducts and current flows back from the Vout pin to the Vin pin. Figure shows an application circuit for a load switch IC. In contrast to a load switch circuit composed of discrete devices, it consists of only 3 components: a load switch IC plus input and output smoothing capacitors. One of the major advantages of load switch ICs is that they incorporate various functions, including inrush current limiting, auto discharge, overcurrent protection, thermal shutdown, under voltage lockout, and reverse current blocking. Therefore, load switch ICs help reduce the board area and improve system stability. Chapter 2, Convenient Functions Load Switch ICs. Useful functions available with load switch ICs. Load switch ICs incorporate various functions that help ensure stable system operation. This chapter describes the operation of each function of overcurrent protection, thermal shutdown, inrush current limiting, auto discharge, under voltage lockout, and reverse current blocking function. Operation of overcurrent protection. In the event of a system failure, for example, when the load connected to the Vout pin is short-circuited to ground, the overcurrent protection function limits the output current to protect the load switch IC in the system in which it is used. When a drop in output voltage, Vout, causes excessive current to flow, Toshiba's load switch ICs limit the output current to the set output limited current, ICL, level by tripping a current limiting circuit. When Vout drops further, Toshiba's load switch ICs perform current limiting called foldback. In the event of excessive current higher than the internal threshold, foldback reduces the output current, Iout, as the output voltage, Vout, decreases. Even when the output voltage is 0, a short circuit current, ISC, continues flowing at the internally set level. The term foldback is derived from the shape of the output current, Iout, vs output voltage, Vout, curve that folds back during protection operation. When a faulty condition causing overcurrent disappears, the load switch IC automatically recovers from overcurrent protection, returning the output voltage to the normal level. Operation of thermal shutdown. In the event of excessive power dissipation or the junction temperature exceeding a threshold due to an excessive increase in ambient temperature, the thermal shutdown function turns off a load switch IC to protect itself in the system in which it is used. Load switch ICs have a thermal shutdown temperature and a recovery temperature. The thermal shutdown temperature is the temperature at which thermal shutdown is tripped to turn off a load switch IC. When thermal shutdown is tripped, the resulting reduction in power dissipation causes its junction temperature to fall. Once it reaches a certain temperature, the load switch IC turns back on automatically. This temperature is the recovery temperature. Unless the cause of the tripping of thermal shutdown is removed, the junction temperature rises back up, causing a load switch IC to enter the following loop: a turn-off of a load switch IC, a decrease in junction temperature, a turn-on of the load switch IC, an increase in junction temperature. The load switch IC should not be left at an excessive temperature for an extended period, because doing so might affect the system stability or degrade the reliability of the load switch IC. Be sure to provide a fail-safe mechanism for a system in case of thermal shutdown. Inrush current reducing. Once a load switch IC turns on, its output voltage increases instantaneously, causing overshoot that might exceed the rated voltage of the load IC or circuit. In addition, a large inrush current flows into the load switch IC to charge the output smoothing capacitor connected to the Vout pin. Inrush current occurs during the period from the time when the load switch IC turns on to the time when the output voltage stabilizes. If the VIN pin is connected with the board trace with large impedance, the input voltage might sag because of a voltage drop that occurs across the trace impedance due to inrush current. This makes the load switch IC unable to provide a normal output voltage level. After the load switch IC turns on, the inrush current limiting function raises the output current slowly to limit the inrush current, thereby suppressing the output voltage overshoot and the input voltage drop. Therefore, inrush current limiting helps improve system stability. Inrush current limiting is also called slew rate control or soft start. Auto discharge. An electronic system consists of multiple ICs and circuits. For the system to work properly, it is necessary to set a power supply sequence, i.e., the order in which to supply power to the constituent ICs and circuits. A relatively large capacitor is connected to the Vout pin of a load switch IC in order to smooth the output voltage. Unless this smoothing capacitor is discharged properly, it is difficult to set a power supply sequence for a system. When a load switch IC turns off, the auto discharge function discharges the smoothing capacitor quickly via the internal AND channel MOSFET connected between the Vout and ground pins, thereby facilitating power supply sequencing. As shown in the figure, the discharge time of the capacitor connected to the output terminal varies with or without the output discharge function. Auto discharge function is effective not only when you want to reduce the output voltage in a short time, but also to prevent malfunction of the subsequent system due to the charge remaining in the capacitor connected to the output terminal. Undervoltage lockout, UVLO. This function comes in handy because system operation might become unstable if the voltage supplied to a constituent IC or circuit drops. When the input voltage of a load switch IC drops below the internal threshold, the undervoltage lockout, UVLO, function turns off its output to ensure system stability. Undervoltage lockout has a hysteresis. When the input voltage rises back above the recovery threshold, the output automatically turns back on. Reverse current protection. The reverse current blocking circuit blocks the current flowing in the reverse direction from the Vout pin to the VIN pin when output voltage more than input voltage. Toshiba's load switch ICs are available with two types of reverse current blocking circuit: A. Reverse current blocking activated only when a load switch IC is off. As shown in the figure, when the MOS pass transistor turns off, VIN becomes lower than Vout to prevent reverse current from flowing from the Vout pin to the VIN pin. Reverse current blocking is disabled while the MOS pass transistor is on. B. True reverse current blocking. A true reverse current blocking function prevents reverse current from flowing from the Vout pin to the VIN pin regardless of whether the MOS pass transistor is on or off. The reverse current blocking circuit is enabled when Vout becomes higher than VIN by VRB, reverse blocking voltage threshold, and is disabled when Vout becomes lower than VIN by VRBR, reverse blocking release voltage threshold. The following figure shows the reverse current characteristics of a load switch IC with a true reverse current blocking function. As highlighted by the red line, number 1, I reverse increases as the difference between Vout and VIN, Vout minus VIN, increases. Reverse current blocking is enabled when Vout minus VIN reaches point A, at which it is approximately 40 mV, blocking reverse current. When VIN becomes higher than Vout by roughly 30 mV, at point B, as highlighted by the green line, number 2, reverse current blocking is disabled, causing current to begin flowing again from the VIN pin to the Vout pin. Chapter 3, Glossary of Terms used in the datasheets for load switch ICs. The following table provides the definitions of major electrical characteristics shown in the datasheets of load switch ICs. Input voltage is the input voltage range in which a load switch IC operates properly. It is represented by Vin. On-state quiescent current is the amount of quiescent current that flows through a load switch IC when it is on. It is represented by IQ. Off-state quiescent current is the amount of quiescent current that flows through a load switch IC when it is off. It is represented by IQ, off. Control high-level input voltage is the minimum voltage at which the control pin of a load switch IC is regarded as being in the logic high state. It is represented by VIH. Control low-level input voltage is the maximum voltage at which the control pin of a load switch IC is regarded as being in the logic low state. It is represented by VIL. On resistance is on resistance between the drain and source of the MOSFET connected between the V in and V out pins. It is represented by RON. Reverse blocking current is the amount of current that flows into a load switch IC from the V out pin when the voltage at the V out pin is higher than the voltage at the V in pin. It is represented by IRB. Reverse blocking voltage threshold is the difference in voltage between the V out and V in pins at which the reverse current blocking circuit is tripped when V out more than VIN. VRB is specified for load switch ICs with a true reverse current blocking function. It is represented by VRB. Reverse blocking release voltage threshold is the difference in voltage between the V out and V in pins at which the reverse current blocking circuit is disabled when V in rises back above V out after it is tripped. VRBR is specified for load switch ICs with a true reverse current blocking function. It is represented by VRBR. Under voltage lockout rising threshold is the threshold voltage at which UVLO is disabled when V in rises. A load switch IC turns on when V in exceeds VUVLRI. It is represented by VUVLRI. Under voltage lockout falling threshold is the threshold voltage at which UVLO is tripped when V in falls. A load switch IC is disabled when V in drops below VUVLFA. It is represented by VUVLFA. Over voltage lockout rising threshold is the threshold voltage at which OVLO is tripped when V in rises. A load switch IC is disabled when V in exceeds VOVRI. It is represented by VOVLRI. Over voltage lockout falling threshold is the threshold voltage at which OVLO is disabled when V in falls. A load switch IC is enabled when V in falls below VOLVFA. It is represented by VOLVFA. Output discharge on resistance is the on resistance of the internal AN channel MOSFET connected between the V out and ground pins of a load switch IC for discharging the external smoothing capacitor connected to the V out pin. It is represented by RSD. Output limited current is the current level to which the output current is limited by the overcurrent protection function. It is represented by ICL. Chapter 4, Power Loss Calculation for Load Switch IC. Calculating the power dissipation of a load switch IC and heat dissipation. The junction temperature Tj of a load switch IC can be calculated as follows. When the term V in multiply IQ is negligibly small, equation 1 can be approximated as follows. The junction of a load switch IC, Tj, can also be calculated in the following manner, where RTH, Ja, is the thermal resistance of the load switch IC when it is mounted on a board. If RTH, Ja, is not shown in the datasheet, you can calculate it from the power dissipation, PD, value, where Tj, max, is the maximum rated junction temperature of a load switch IC. Substituting equation 4 into equation 3, we obtain equation 5. Substituting equation 5 into equation 2, we obtain equation 6. The power dissipation of a load switch IC can be calculated as shown above. The on resistance of the load switch IC depends on temperature. Use an appropriate on resistance value according to the actual usage temperature. Note that the power dissipation and thermal resistance values in the datasheet are the values under the specified board conditions. It is therefore necessary to evaluate load switch ICs carefully to ensure that they work properly under actual usage conditions.